A creature from an alien planet. Its body temperature is varying sinusoidally for the time. 35 minutes after it starts timing, the alien's temperature reaches a high of 120 degrees Fahrenheit. 20 minutes after that, it reaches its next low, 140 degrees Fahrenheit.
Okay, so it says draw a graph to represent the situation, and let's go ahead and label these axes. So what does this one represent? The x-axis. Time, and yes, we are in minutes. And what about the y-axis? It's going to be, yeah, temp. You can put in Fahrenheit if you want. Okay, so we don't know a lot, right? We know 2 points. So what points do we know?
We know 35 and 20.
30 at 35 minutes. What's the temperature?
120.
120. And what else? At 55 minutes. Where did we get 55 from?
20 minutes after 35 minutes.
Right. 20 minutes later, it reaches its low, which was at. So this is basically all we know.
Thank you.
But it's enough, right?
Oh, that's enough. And we don't have to like fully write the cycle, do we? Okay, just.
No, you can just graph, that's fine. Okay. So we want to write an equation. So we need A, B, H, and K. Okay, A is the amplitude.
It is 8.
Okay, 16 is the distance from, yeah. So we're doing 120 minus 104 divided by 2, which does give us 8. So the amplitude, we subtract the 2 that we have, the high and the low, divide by 2. So B is 2 pi divided by the period. What's the period?
40.
No, I'm tripping 40. Yeah,
Why is it 40 and not 20?
because that's just half of the cycle.
Right. From the high to the low is half a period. So this is 20 minutes. So the whole period, which means we would get back to the top, is 40 minutes. So that does reduce to pi over 20. Okay, H, how much did we translate?
35 to the right.
We went 35 to the right. We're just starting at this point here. And then K, what's K?
100. Wait, no.
112.
112.
So we can add those two together. 120 plus 104 and then divide by 2. Remember, K is just the average of those two things. So that's 224 divided by 2, which is 112. Are we writing this as a sine or a cosine graph?
Cosine.
Cosine. So f of x equals. Now, is A going to be positive or negative if we're starting at this point here?
Positive.
Positive. So we have 8 cosine B, right, which was pi over 20,
Minus 30.
x minus 35 plus 112. Okay. Now, usually, guys, on these, you're always going to have, you have to write the equation, and then you're going to have one of them where it gives you the x, and one of them where it gives you the y. So on C, if it says, what's the temperature when T equals 0, what are they giving us, the x or the y?
The X value.
They're giving us the x. So I would probably put this in your calculator.
Pi over 20.
So 8
Bless you.
cosine. Here's where people have been messing up when I look at your So after this pi over 20, let me zoom in. Do not close the parentheses there. You open a new set. X minus 35 and then close twice. That's where people keep messing up. You're closing after the x over, pi over 20. Don't do that. Open, B, open, x minus whatever, close, close. Plus 112. Okay, so we need to adjust our window, right?
Yes.
What are we thinking on the window?
X 0 to 55.
0 to 55. Okay.
And then Y like 104 to 120.
104 to 120. Works for me.
Minus 0.
Again.
I mean, X-Men. Sorry.
Oh, yeah.
I said X-Men. Sorry. That has to be like the.
So now let's just hope we did it correctly. Thank you. Okay, so what does it ask us? When time equals 0, what's the temperature? What do we do?
Table or second values.
Or just trace. And then type in the number 0. But yeah, you can go to the table, it's fine. Any of those would work. 3 decimal places. 117.57.
So always the thousands. Okay.
Yeah, let's just do that. All right. And then D says find the time when the temperature reached 114, the first time.
First.
That can be the intersect.
Yes. So we got to go back to y equals, type in, what was it, 114?
Yes.
And we're looking for the intersection. Now, when we graph this, we have 3 different intersections. Which one does it want? The first one.
That's a time like whenever.
So second trace, intersect. If I just start hitting enter right here, it's going to give me this intersection. I don't want this one, I want this one. So you got to move your cursor over. This be taken forever.
So this one, when it says first time, is it always the first intersect from 0?
All right, that's what I got, 3.391. Is that what it said on the back? And that's in minutes, right?
Yes.
This one was degrees.
Wait, would you have to change that to 3.39 minutes to seconds?
It's always talking about the first quadrant. It's not going to ask us about the negative, like the second quadrant. Like the first time, the second. Yeah.
Wait.
Yes.
So like when it starts us off,
Guys,
when it starts us off with like 35 minutes, like away from 0, and it says like what was the first time the temperature reached? Like a
Yeah.
certain number, you start from like 0, 0.
start from 0. Yeah. Because they only marked the high once it got over here.
Yeah.
So when we graphed it, we graphed this part, but he was close to a high over here. So they started his temperature. We actually got to a minimum before we got to a maximum. But we only know about the first maximum. But yeah,
Are they gonna be
start at time
questions
equals 0.
more like the ones on here, like the ones we found?
Either?
Either.
Yeah.
I just feel like these are like a little bit more like
Easy or hard?
harder.
Oh. They're not crazy hard. I don't. I've got
It's
smart.
obviously